When we come home late from work and fumble for the light switch in the dark, we expect the light to come on immediately when we flick it on. But the power that provides that illumination is not stored locally. So how does the light turn on instantly? Our electricity needs are met by the power grid. A power plant generates electricity remotely, which is then transmitted to a local substation. There it passes through a transformer and is converted into a voltage that is usable before being distributed to our homes and offices across a network of high-voltage power lines collectively known as the power grid or grid. At times when people are wanting to use their electrical gadgets and appliances simultaneously, demand for electricity increases and are referred to as periods of peak usage. When you, your neighbours, and millions of other people all turn their lights on when they get home from work at the end of the day, the power grid's demand load is increased. One method of reducing this demand load is through demand response, actively reducing energy usage over certain periods of the day or night, according to peak demand. Demand response can be achieved by reducing power usage or by generating power on site to meet the customer's power needs and reduce their dependency on the power grid. Demand response programs are currently being used in commercial and residential buildings, typically incorporating dedicated control systems that enable load shedding in response to consumer demand at the request of a utility company, or to reduce consumption during peak periods when electricity tariffs are much higher. Non-essential services such as lights, air conditioning systems, or other machinery that are not needed are automatically switched off during periods of critical power demand, or when electricity rates are highest, according to a pre-planned schedule.